I think next one is Pierre. I don't know if he's aware that he's speaking. Cosmina, have you seen Pierre? Thanks. There were 2 microphones. Now I have a full collection over here. Huh? So Cosmina is getting Pierre. He's the last one, and he has, yeah, see? Sometimes people are finishing early, so you might better be around. The good thing is I don't have to introduce Pierre anymore, and he is the last one, has the difficult task because he is between you and lunch. So we got 3 working microphones over here. You can choose whatever you want to have, huh?
Hello? Yeah. I will just ask you for patience for 1 minute for me to share and start my screen. Okay. So I've been asked already this morning if the slides will be available. Of course, they will be available. They're already available on the membership platform. And I'm quite sure that we will ease that and provide you a link also, maybe somewhere in an email or a recap of the conference. So, keynote and trust index. I have to do a bit of Windows wizard thing. Don't worry. It's because I have 3 screens, and basically the display otherwise is not the correct one. And I click on the wrong button, so we have to start again. Keep changes, and then I can duplicate again, and then it will work. Sorry for that. Extend, duplicate 1 and 3, and here we go. Keep changes and presentation mode. Again. Yeah, cool. So trust indexes. Sorry for that hiccup. Data doesn't flow on rainbows. Don't need to explain that one. Data flows on services. So when I've said earlier before, what is data? I will have a very generic definition for data today. Data, that's the digital representation of information. It does include metadata. So the data about the data, that's metadata, but you can extract metadata out of the metadata, that's a circle. I will just keep it simple. Data, that's a digital representation of information. You don't monitor or observe data. You monitor the service that process the data, and so on. That's one of the things I've said earlier this morning, and I think that's important enough to be repeated a second time. You don't copy data out of thin air. You need services to copy, to transfer data. part of the work that we are doing, and that's going backwards, that's interesting. Okay, I might stop using something fancy, just back to proper mouse keyboard. And because data flows on services, and if you want to enable the so-called data sovereignty that I put into quotes for the reason we've mentioned this morning, you want to have control, visibility, traceability on your data. You want to have then control, visibility, traceability on the service that are processing, storing, transferring your data. And independently on the nature of the law obligation or the obligation that you have, that might be privacy notice, terms and conditions, consent, and so on, you will have a need to express to gather additional information about your services. And that's exactly what the Gaia-X compliance document is about. The Gaia-X compliance document, that's 4 assessment schemes with different criteria for each of the assessments. But also, to be noted that those criteria applies to data connector. A service, a data connector, is a service. I mean, a data connector, if you just check out the source code, it will not run and do anything. You have to instantiate it. You mean that you have to turn the source code, to compile it, turn it into a service. So when you have requirement such as the PRC, the compliance document on services, it does include data connectors. Those pillars, assessment criteria, we have 4 of them. The Gaia-X conformity, the Gaia-X label, and within the label we have 3 levels, 1, 2, and 3. The point today, because the presentation is going to be quite hard already on mathematical formulas, I'm going to skip that, what is inside each of the conformity assessment. But you can see that as Gaia-X conformity, that will be like giving you the grade number 1, and then label level 1, 2, and label level 2, 3, and level 3, number 4. And that will make it clearer in that slide. It's like if you have a scale, that once you reach conformity, you have 1, then you have on the scale label level 1, that's the second one that we named 2. Maybe for ease, I will have number that like in C from 0, but then label 0 sounds nice, so I prefer to start from 1. The challenge that we have is those are very static set of rules. What if you are somewhere in the middle? So you describe a bit more than what is required for conformity, but not enough to be Gaia-X label level 1. Or if you are describing something which is not part of the compliance document, where do you see yourself on that scale? The other thing, imagine that we have a catalog, like the one that we had in the Gaia-X Summit in Alicante last year. We had 8 data spaces connected together, sharing product, sharing services. We had about 100 of them, 140 something. If they are all Gaia-X compliant, they were all Gaia-X compliant, how do you order them? Hey, I'm a catalog, I want to have all Gaia-X compliant services. Boom, thousands of them later, maybe in the future, near future, I hope. How do you find more granular measurement for that? Well, that's how the Gaia-X trust indexes were born. And for the next part of the presentation, that's why I had the laptop set up. It's because instead of copy-pasting things from one document online to slide deck, which was not looking good, I decided for that one to just go on the website and use that to show you how it's being done. So the trust indexes, and maybe I can finally reuse that one, yes. Trust indexes, we have 4 trust indexes. Veracity, can you read that clearly? No, that's look awful. Too much maybe? Better? Better. You have 4 different trust indexes: veracity, transparency, composability, and semantic. For today's presentation, looking at the time also, we will go through only the first 2. And the reason is because only the first two have been implemented. The implementation of everything I will show today is done directly in the web page. So instead of having a snapshot of something that I generate and then copy-paste, all the formulas are directly in the JavaScript source code page, source code of the page, so everything is generated dynamically. For the trust indexes, again, the rationale of why those were created is because we want to measure more granularly what's happening within those 4 conformity schemes. And without further ado, let's go to the first one, veracity. Don't get scared about the mathematical formula. They are just a way to agree with different parties how to compute that. Maybe directly going to the example. If you have a claim, you have a contract or your product, and this is being signed by a very, very long chain of certificate, like that one, yes, that's the second example. A very, very long chain. Every time you have a new additional certificate in your chain of certificate, that's like a right delegation. The longer the chain is, more right delegation you had, less trustworthy the claim being signed at the end is. In the common world, when we talk about SSL, EVSSL, and EIDAS, you usually have a certificate X519 with only 3 hops: the root certificate, the intermediate, and the leaf. If you want to describe everything down to the hardware, you might have EIDAS, fair, and a qualified signature for the legal appointed representative of your company, the CEO. But the CEO will delegate right maybe to the CFO to the tech lead to one of the developer to one of the machine, and then the machine might start to communicate with each other. You have a lot of protocol in the OT, in the manufacturing, that starts to use also protocol to communicate with each other from one machine to another. So this chain of certificate and digital signature can be rather very long. And the longer it is, less trustworthy is the information at the end. How do you measure that? How do you automate that? Turns out that if you have different of those chains, so the claim is not being signed one time, but by different chain, then you increase your level of veracity. The formula is just measuring that. Basically, that's the sum of all the length of the chain. And because we have to measure that as an index, all the formula were crafted so that the index at the end are between 0 and 1. That's why there is a bit of wizardry with the normalization. So the index will evolve like that. If, for example, I take the index of with an alpha 0.9, that will be the curve in blue. As my chain goes longer and longer, if I'm signing things myself and I'm a root entity, it's 1. I am me, and I care that I'm me. I have the certificate. Fine, you can trust that. If I start to delegate that more, longer is the chain, less likely or more likely there is someone malicious within that chain that might do something wrong, not necessarily on purpose, but something wrong might happen. So that's how we might degrade this trust index for veracity. Why that's important? Inside the policy rules document, the compliance document, sorry, it will be extremely hard to mandate exactly what needs to be done at every steps of the process. And we cannot possibly describe every possible use cases of every warehouse, machines, everywhere. So we have to enable some level of flexibility. We have to tell, here are the certificates that we seems relevant for signing something. And then within that data space, within that ecosystem, if there is a very long chain of certificate, that's up to the data space to find a way to measure that. And the trust index are exactly here to answer that question. That's enabling this bit of additional complexity, is enabling some flexibility in the measurement of that trust relation that you have between participants. The transparency, so just by raising your hand to get a bit of the temperature, how many of you understood that one? Okay, good. We can move to the funnier one. The transparency index. So here that was about how many certificates were used, or what was the length of the certificate to sign the claim. Now this is a bit what is being signed and how much has been described. So that's about the transparency. The transparency, very important, that's not about compliance. Compliance, that's a set of rules that's really binary. You are compliant or you are not compliant. Transparency, again, the intent here is to give you a number between 0 and 1. And you can compare transparency index only between or within the same type of information. If you describe a database, it makes sense to compare the transparency only for another database. It doesn't make sense to, for example, compare a database with a load balancer. They don't have the same criteria. You will not describe it the same way. Hard. So the transparency index, again, that's something that is between 0 and 1, and need to measure two things. But before we deep dive into how that's being done, let me give you an example. Part of the policy of the Gaia-X compliance document, we have this criteria that says, for a service offering, here I have a fortune teller. Fortune teller, that's just an API that returns sentences. You need to have a provider. Very simple criteria. And in the graph relation of those claims, that will be as simple that you have on the screen. One service offering provided by something else. What if you want to describe a bit more? So the fortune teller is an aggregation of a software which is also provided by a provider. Here, in that case, for simplification, that's the same provider. You provide a bit more additional information, and you can go way deeper in that. My fortune teller, that's the data set from someone else, and maybe an open source data set. Here you can maybe find the analogy with AI and how you train AI model. Where the service is located, a data center, which software, operated by who is the tenant of my services, and so on. All those pieces of information can be used later, for example, if you want to deduce what is the jurisdiction, or what I call legal autonomy, operational autonomy, or technical autonomy that you might have with that services. Again, we cannot mandate to be as precise when describe every services as part of the compliance document, otherwise we will just kill everyone. But some parties, we like to be more transparent than the others. How do we reward their additional effort to be transparent? That's what we provide here. A way to measure that. And then there is an example of how to do that. So for each verifiable credential on the graph, we weight those credentials. Further down the graph you are, less impactful you will be on the trust index. If you have a service description and you even describe where the hard drive is located, even if you describe your full set of hard drive with the speed and the type of VRAM which is used in the SSD and so on, it's not going to be very impactful for your high-level services. So further down the graph description, less relevant or less impactful you will be on the overall trust indexes. I'm going to skip that part. And here, I'm going to give a table that fits inside the same screen. So you have different credentials, VC1, verifiable credential 1, 2, and 3, same type. And they have different attributes. So proposition 1, attribute from 1 to 6. And they have different cardinality. And what is being computed here on the screen, by the way, this computation is being done in JavaScript. If you want to look at it, if you want to modify it, if you want to experiment with that, you just look at the source code of the page. It's pure JavaScript. There is no fancy framework. You edit, you play with that. It will compute a transparency index for this VC specifically. So here, I'm just going to take the last two columns. I have a verifiable credentials, and I fulfill all the mandatory, for example, all the criteria, proposition 1 to 6. The difference between VC 6 and 7 is that here, the proposition 5, which had an unlimited cardinality, many, and 6, which has also a cardinality of many, I move from 1 to 2 and 1 to 6. So it's slightly more transparent. I've described slightly more than what was just required at the beginning. So you get a slightly bigger score. So from something which is 0.08 to 0.0693. That's a level of transparency per credential. But you remember that when you describe your services, you have a chain or a graph of credentials. So you need to incorporate then this transparency index into the graph. So that's the evolution of the trust index, visually speaking. Again, generated in JavaScript. That's dynamic if you want to play with that. And then we had to find a way to measure that again, between 0 and 1. So I skip the mathematical explanation. But basically, if you have here a service offering that is composed of resource 1 itself, resource 3 and 4, and then resource 2, depending of the, so again, an example, dynamically generated in JavaScript, if you want to play and fine-tune and experiment, please look at the source code page. You have a service offering where each of the VC have different trust indexes. And you see that the overall score being computed is also different. So here it's by column, that's different example. And the service offering, you have trust index 0.2 here, for example, and then the trust index of the VC offering is 0.5. The trust index of the resource 2 here in the example 1 is just 0 because I haven't described anything. In the example 5, I went a bit beyond, for example, maybe what is required, and my trust index of the VC about the resource 2 has a trust index of 8. When I aggregate that together within the mathematical formula, that will give you an evolution of the trust index, meaning that my service offering, example 1, when I just describe the service offering because my resource 1, 2, 3, 4 are not described, that might be Gaia-X compliant. But the overall level of transparency is rather low. The same Gaia-X compliant service offering, because I'm a provider and I want to be more transparent than what is only just required, I will describe more than what is required. I will get a trust index of 0.5. And while this sounds, and here you have the evolution. Those trust indexes are not here just to be having fun with some mathematical formula. That's to give an incentive to be more transparent, because otherwise we will have to constrain too much. We cannot constrain each provider to describe the same way across all the data spaces, all the ecosystem. That will hell of a burden. What we can provide, and for someone who has done some gradient descent in their academic background, you in fact provide a metric. You have a starting point, and you have your destination. And what you do, you have an iterative algorithm, and for every step of the algorithm, you measure how far you are from your objective. That's what we provide with the trust index. We are not going to mandate go there, because then everyone will say, I don't want to go there. My personal opinion is that I should go slightly left, slightly right, and so on. Maybe my requirement for my ecosystem doesn't require me to go as deeply as that in my description of services. So what we provide with those trust indexes, it's like a metric of how far you are from the objective to help the market to converge. The other added benefit is that when you have a catalog, and I hope that soon we will have thousands of different data product offering within this network of catalogs, how do you order them? One of the questions also that we want to answer, and that will be with the composability and semantic match, and for that we are just prototype things like within the lab, and I hope that we will be able to demonstrate things soon. One of the questions that I want to answer, because Gaia-X, we talk a lot about interoperability, and the question, I think I even wrote it down in that slide, in that document, which is part of the architecture document 2404. You are a provider, and you want to make sure that your services is as widely as possible usable, can be adopted as widely as possible. And you ask a question, I will push my services inside, interesting. I will push my services in the catalog. How can I measure how interoperable with other services I am? For example, I'm a cloud provider, and I want to make sure that I have a lot of SMEs. They can deploy their VM, they can deploy their AI model, they can deploy their application on top of my infrastructure. How do I measure that? How do I measure that what I've described enabled them to compose their services with my platform? Gaia-X compliance alone will give you the baseline. The trust indexes will give you a measure of how semantically compatible you are, composable you are with the rest of the catalog. I see a lot of faces that looks a bit puzzled, so I will stop here. I will just maybe give an overview of the composability and semantic match, and maybe take question. Thank you for the notification. The composability, that's the capacity that we want to have, especially for SMEs, small medium company, small medium enterprise in Europe. We know that European economy is mostly based on SMEs. How do you take those SMEs to work together? Either we mandate something by the regulation, we enforce, and I think that's going to be a disaster. I don't think that's going to work, or it's going to take a lot of time. What we could do is that you have your service, you describe as much as you can, and I'm going to provide you the tools that enables you to measure if your service can be composed with others. So it's not Gaia-X leading how that needs to be described. We provide a tool, like a rule to measure, and then the market drive itself. Because maybe there are some trend for specification for software. And Gaia-X is not here to mandate which software to use. If there is a data space that wants to use only, I don't know, Kubernetes, and another one OpenStack, Gaia-X is not going to tell them, yeah, you need to use that one or that one. That's within the ecosystem. They need to measure how compatible they are. And the semantic match, it's a very challenging one. That's going to be relevant for the expression of the policy. As I mentioned before, we have a lot of different policy being expressed everywhere. From the day you onboard inside your data space and your ecosystem, to the privacy notice, to the data consent, the consent management of your data, the processing purpose of the data, you have a lot of policies that are being expressed. Right now, when you look at the state of the art, you have a PDF, and you express that as a PDF, and then you need to say, here I hereby accept the terms and conditions. What if we have a way to make sure that the terms and conditions I sign with the service A that I want to use with the service B are compatible with each other? That will be the semantic match. Even if we could dream that every policy rules can be expressed in ODRL, which is Open Digital Right Language. Even with that, we will have some challenges on measuring how much those ODRL policy can be used together. So that's what the semantic match is about. And again, we have some of the hacking session today that work on that, so I'm very happy to have people around looking at it. With that, I'm a bit in advance. I know that was a bit dense and complex compared to what we usually have in Gaia-X. But the trust index, I do really believe that's a way to go beyond just those not the data doesn't flow on Rainbow, but that one. Because this one will give you very binary information, which is good. It's a good starting point, and that's required. That's very objective. And needed. But I would like to squeeze some numbers in between. So from integers to floats. With that, thank you very much. If you have any question, we do have a few minutes left. And otherwise, you said that I was between like this presentation and lunchtime, so I can understand, of course, that you prefer to go and run for lunch. Thanks a lot. Staying at your disposal if you have any question.
Thanks a lot, Pierre. Really, really happy to see that stuff is advancing from integers to floats. That's definitely